Okay, ladies and gentlemen, welcome. This is the video I promised you guys of me walking through the spring midterm review for geometry. Again, I'm not reteaching anything in this, I'm just walking back through what I did so you don't have to just follow work, but there's some sort of audio overlay. So anyways, problem number one, I need to write it out on paper because I need more room. So copying it onto paper, I've got x to the 1/2, y to the -3/2 times x, all over 4, x to the -3/4, y to the 3/2 times 3 times x times y. First thing I want to do is notice, is there anything that's really easy for me to get out of the way? I notice I've got an x on top and an x on bottom. They're gone. Second thing I want to do is I want to get rid of any negative exponents. So I've got y to the -3/2. I can make that a positive by moving it to the other side. And I can make this x to the -3/4 into a positive exponent by moving it to the top. So rewriting what I had, so I had x to the 1/2 still up top, and now I'm adding this new x to the 3/4. It became positive exponent when I moved it to the top. Down here on the bottom, I still had 4, I had y to the 3/2, and I had 3, and I had y. And now I have this y to the 3/2. Moved it from the top down, made it into a positive exponent. Here, simplify the top and the bottom, multiplying same base, different, or doesn't matter what the exponents are, we add them. So we keep the base, add the exponents. 1/2 plus 3/4 gives me 5/4. And down on the bottom, I've got 4 and 3, that's 12. And I've got y to the 3/2, y to the first, y to the 3/2. When you combine all of those, same base, keep the base, add the exponents, and you'll get 4. So x to the 5/4 over 12 times y to the 4th. Perfect. Number 2. I've got 2n squared minus 2n to the 4th minus 6n, and I don't know if you can see that. If you couldn't see the last one, I apologize. There you go. Sorry, I'm still going to reposition. Let's try that again. So here's this one. This is number 2. 2n squared minus 2n to the 4th minus 6n minus, and that was in parentheses, minus 3n to the 4th minus 3n plus 8. First thing I need to do is distribute my negative. So that's going to give me negative 3n to the 4th plus 3n minus 8. And I have what hasn't changed up here, 2n squared minus 2n to the 4th minus 6n. Combine like terms, negative 3n to the 4th and negative 2n to the 4th. It's going to give me negative 5n to the 4th. I've got 2n squared. I've got nothing else with an n squared. Just as a reminder, like terms are based upon same variable raised to the same power, and then I can just add the number part in front. Like this one, negative 6n, positive 3n, negative 3n. Minus 8, no other number part. We're good to go. There's your final answer. So there's 1, 2, 3. Same thing. I'm going to copy it down on here. So I'll have 7 minus 4i. I'll move it up so you can see it a little bit. Times negative 1 plus 3i. Double distribute, so take this, distribute it to everything in that other parenthesis. Take this, distribute it to everything in that other parenthesis. So just distribute twice. 7 times negative 1 is negative 7. 7 times 3i is positive 21i. Negative 4 times negative 1 is positive 4i. Negative 4 times positive 3 is negative 12i squared. Recap just a little bit. I is equal to the square root of negative 1. So if I come in and square both sides to get I squared, square root of something squared is just itself. So the square I squared is just negative 1. So here I'm going to replace that with negative 1. So I'll end up with negative 7. 21i plus 4 is a positive 25i. And negative 12 times negative 1, remember that's a negative 1, is positive 12. Negative 7 plus 12, 5 plus 25i, and it is typically written with the real part and then the imaginary part second. So 5 plus 25i. Number 4, let me I'll show you the problem real quick because there's a little bit of geometry in this one besides just the straight algebra. We've got two parallel lines cut by a transversal. I've got my alternate exterior angles. They are congruent. So I can set them equal to each other, congruent meaning the same angle measure, so I can set them equal to each other. So I'll have 6x minus 2 is equal to, move the paper, 27 plus 4x. There we go. 6x minus 2 is equal to 27 plus 4x. Solve. So I need to get all my variables on the same side, subtract 4x from both sides. 2x, add 2 to both sides, is equal to 27, 28, 29. Divide both sides by 2. X is equal to 29 halves. Can't simplify it anymore. If I ask for an exact answer, I want the fraction. Okay, divided both sides by 2. I want the fraction as my exact answer. It's as simplified as it goes. We're good to go. If I want a decimal approximation, you can plug that into your calculator, 29 halves, and get 14.5. Number 5. So I'm going to take away my scratch paper because I don't need it for just a moment. Find the vertex of the graph. The vertex is the graph where is the point on the graph where it changes direction. So here I'm going down, now I'm going up. You can. It's also been referred to as like a point on a graph, like a mountaintop or a valley. And we'll get into, in calculus, you'll get into more of the actual definition of what it is and local and anyways. So vertex, there's that point. It's 2, negative 9. The x-intercepts is where the graph crosses the x-axis, here and here. So we have negative 1, 0. And we have a second one at 5, 0. So those are my two x-intercepts. Sorry, I had to scribble something out. Found this one on the floor. Y-intercepts. It's where it crosses the y-axis, right there. And the y-intercept for this one then is going to be 0, 1, 2, 3, 4, 5, negative 5. 0, negative 5. So there's the y-intercept. There's only one in this particular case. Find the zeros. Zeros are where it crosses the x-axis. So here x is equal to negative 1 and 5. Also, some people will write it as the 2 points. I usually write zeros as the x equals. Maximum or minimum. This is the minimum point for y. Max or min's talking about values of y. This is the lowest point, so it's going to be the minimum. What is the maximum or minimum? It's that point. 2, negative 9. Or some will say, okay, well, since we're talking about y, what is the lowest value of y? And that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9. So that's the point, and the value of it is y equals negative 9. What is the domain? Domain is what possible values of x. In this case, we're looking at negative infinity to positive infinity, because this goes on forever and ever and ever. So any number I pick x is eventually going to hit up with the graph on either side. What is the range? That's what y could possibly be. So the lowest number y could possibly be, we said, was negative 9. And the largest number y could possibly be infinity. Is the function 1 to 1? Remember, 1 to 1 means the function and its inverse are both functions. So essentially, it and its inverse are both functions for it to be 1 to 1, which means it has to pass the vertical line test to see if it is a function. In this case, it does. And it also has to pass the horizontal line test to see if its inverse is a function. This one does not, because if I drew a horizontal line, it would hit the graph twice, thus causing a problem. So no. Okay, number 14. A 47-foot flagpole is 93 feet from the school building. Student stands, etc., etc., etc. Okay, this is ratios. You don't even have to use any trig. The full distance and the flagpole height, 93 over 47, is equal to, because the sun is still casting the shadows and all that fun stuff and looking up at it in ratios, and we did a lot of talking about that, 25 over x. There's my ratio. Cross cancel, 47 times 25, 93 times x. And I did all this work, so I don't want to do that one in my head. And you end up with, okay, we're going to do it on a calculator. 93 times x, 93x. And 47 times 25 is 1175. Divide both sides by 93. And x is approximately equal to 12.63 feet, because we're talking about how tall that student is. Again, this is not drawn to scale. There are no students that are 12.6 feet tall. This is math. Number 15, last but not least in this section, odd, even, or neither. Odd, even, or neither talks about what happens when I plug negative x in for x. So what happens when I have f of negative x? If when I plug negative x in for x, I get the exact same thing I started with, then it's even. If I plug negative x in for x and I get the exact opposite that I started with, it's odd. And if it's neither, then neither. So I'm going to plug f of negative x is 2 times negative x squared plus 11. Negative x squared, negative x times negative x, is just positive x squared, still times 2, still plus 11. So f of negative x is equal to exactly what I started with. If you look up here, 2x squared plus 11, I ended up with 2x squared plus 11, so this is even. Okay, ladies and gentlemen, enjoy. Also, double check my answers against the answer key posted online. If you have any discrepancies and you're right, I'll give you bonus points on the test. Otherwise, enjoy. See you part 2.